Definitely, definitely. Yeah, hello everyone, and thank you for Karim for inviting me to sit here and have a conversation with you. So a little bit about myself. So I got my degree in mechanical engineering from Texas Tech University. It's actually kind of funny because all I work in now is electrical engineering. So I don't know
Yeah.
why I went with mechanical, but right
And you're a
whenever
guy from Houston,
yeah, yeah,
the,
and I'm
the the
and I'm in
the home of
Houston.
the oil industry, and yeah,
I know, right? Yeah.
yeah,
Why am I in renewables? Crazy.
yeah,
Uh,
yeah.
so right whenever I graduated, I went to work for a company by the name of Innovative IDM, and that's where I kind of cut my teeth, if you will, on the electrical industry. So that company, we had a large focus in industrial electronics. So on a daily basis, I would, be going into these manufacturing facilities and, looking at AC motors, DC motors, variable frequency drives, maybe their HMIs or their PLCs, which are programmable logic controllers. So I got kind of a really good basis of understanding on electrical systems then, and really, really enjoyed working for them. We even manufactured some full electrical cabinets and whatnot. So really got like a good idea of looking at, single line diagrams and things like that. And then from there, I actually transitioned over into renewables with Q cells. So
Mhm.
what ended up happening there is I had a good friend that I had worked with at Innovative IDM, and he was like, "Hey, you know what? Let's be slightly better people and work for a renewables company." So I was like, "All right, well, let's do it." And I started working for Q Cells. There, I was a field applications engineer. So
And you're in the module business of Q cells, I assume,
not on
or
the module side. So it's
oh,
actually interesting. Yeah, Q Cells has a battery division as well.
mhm.
And
Okay.
if you look at the topology of an inverter for a battery,
Hmm.
or even for a PV inverter, the topology is just like the topology that you find in a variable frequency drive. Now, there are a few different things here and there, like one uses MOSFETs, while the other one uses what we call IGBTs, but that's kind of getting into the nitty gritty.
Yeah.
But overall, the bridge structure is fairly similar. So whenever I started working for Q Cells, I kind of had a pretty good idea of what I was getting myself into. But as a field application engineer for them, my main thing was usually going out and fixing these sites that for some reason were having issues, or providing technical trainings for people who would be working on those sites, and so on and
Mhm.
so forth. So I got a really good kind of look at the solar industry as a whole working with them. Now with them, I worked mainly on what we would call split phase, or residential type of systems. So after working with them for a while, I realized, well, I kind of learned a lot, and I think I'd like to go into something that's a little bit higher power. And that's actually where CPS came along. So I've been with CPS now for, I want to say, 9 months or so, just shy of a year. And with CPS, I now focus heavily on the CNI and utility scale ESS systems that they have. Now, we actually also have a split phase system as well, or residential, whatever you'd like to call it. But I try and shy away from working on that one. I like the big stuff.